Hello everyone. So let's understand the other most important design pattern which has been used in the software industry, which is the observer design pattern. So what is the observer design pattern? So it's a behavioral design pattern that defines one-to-many dependency between an objects, which are basically known as observers, and the other subject and the other object, which is basically the subject. So whenever the subject changes its state, its dependent observers are automatically notified and updated. So let's understand where it could be like take an example to better understand this definition. So let's say when you have a channel created by a content creator on YouTube. So as users, we subscribe to that channel. So whenever a new video is getting uploaded or any new content is getting uploaded on that channel, the notification is sent to the subscribed user. So this is one of the basic or very daily, really basic example which has been used in our day-to-day life to understand this design pattern. Now let's understand like how to identify this pattern. So when you have multiple parts of the system that needs to be modified due to change in one central component, or you want loose coupling between the publisher of the data and its subscriber, then this pattern becomes a good candidate to be chosen. Now let's understand the class diagram of the example through which we'll understand this pattern. Okay. So here I've taken an example of again an e-commerce application. So let's say in the process of placing an order. So whenever a user checks out an order, so when let's say the order is getting placed, so there are various events that needs to be triggered once the order gets placed. One could be changing the count of that item present in inventory, and once it is successfully placed, the notification needs to be sent to the user that the order is successfully placed. So let's consider understand this example using this pattern. So let's say the subscribers for this scenario here are different services. Let's say the inventory service that needs to be modified, inventory service which is taking care of managing the inventory that needs to be modified when the order gets placed, and the notification service which takes care of sending the notifications to the users that your order has been placed successfully or whatever the custom logic it is implementing. So I've created here an interface, basically subscriber, which holds a notify event as a method, and it has a parameter of the order. So order is basically the order which contains all the information regarding the order ID, order name, and the quantity of that order present in the inventory basically. So let's say when a user and the inventory service and the notification service are two of the classes which is implementing this interface. And the definition of whatever logic needs to be implemented when this event takes place, basically when this event takes place, basically placing the order. So that custom logic is defined in the respective services. And I've also created an order service class. So now let's say the order service class also holds an instance of the subscriber, because basically it's an array list, which is a list of subscriber, which it is holding. And we have different methods present here. One of it is add subscribers. So basically add subscribers functionality or responsibility would be to add the subscribers. Basically it could be an inventory service, notification service, and so let's say in future there's some one more service which is getting added, and we can use this method to invoke and add the subscriber to our list of subscribers. Now remove subscribers is basically, let's say we don't want the subscriber to get subscribed whenever the change happens, so we can remove it from this list, basically list, and we can invoke this method remove subscriber to remove subscriber from the list of subscribers. Order is nothing but an action which is taking place, and on base of which the state of the subjects changes, and hence based on it we call the notify subscriber method to notify our subscribers which are subscribed to here whenever there is change in this event. So client basically does not directly communicate or doesn't invoke or have any knowledge about subscribers. So it comes to the order service class and performs whatever the action it has to perform. And also here the this arrow, the dotted arrow, represents the implements functionality. So it's an interface, and these two classes are implementing it. And this is the composition symbol. So basically, as the subscribers instance is getting holded at order service class, so this is what it has a relationship defined here. And now let's understand the code walkthrough about this class diagram and the example which we took to understand this pattern. Here I have on the right hand side opened the same diagram which I had explained previously, and on the left hand side we'll have its code implementation. So it is basically implemented in Java. So first we'll understand the order class. So order class, as I mentioned, is nothing but which contains the details about the order, being its ID, its name, and the quantity. So that is what it is present in the order class as its attributes. And this is the constructor of this class. So its functionality would be whenever an instance of this class is getting created, it instantiates the order ID, product name, and quantity with the respective values. And as this are the private attributes, this could not be accessed, its values could not be accessed from outside the class, and hence I have created a public method to get its values whenever this instance got created, whatever the value it's instantiated. If I want to access it, I can call this method from outside this class and access this. So basically, get order ID returns the order ID, product name returns the product name, and get quantity returns its quantity of the basically what's the quantity this order is holding. Now let's understand the interface subscriber. So basically this has the notify event method, and which has return type as void, and it also holds up one of the parameter, which is the order, which has all its details pertaining to that order. Now two of the classes, which is this inventory service and notification service, implements this interface. So let's check the how it's implemented there. So here the inventory service class implements subscriber, as this class is implementing it, and hence it has to define its definition for this method notify event in this class, and this could have any of the custom logic. So let's say, for example, if you want to have a custom logic of, let's say, when order gets placed, we want to reduce the quantity of that item uh, for that particular order. So we can have that logic implemented here. But right now I've just kept it simple for just understanding purpose, and I've added just the print statement which tells me that this product name's quantity is getting updated basically. And now let's understand the notification service. So similarly, this is also implementing the subscriber interface, and hence it has to give the definition for the notify event, which has a parameter order which contains the detail of that particular order. We can also have the custom logic added here, but this is just the example to understand, and hence I've not implemented that logic here. So, and just added the print statement to understand the flow, how it's working when we run this end to end. And hence I've added just the print statement that notification service is sending notification for this particular order ID. And now let's understand the order service class. So Uh, the order service class is also, as I mentioned, that is holding the list of subscribers. So basically, this is a list of the subscriber as its type. So this contains subscribers, and hence this is this instance basically. And I can have this different methods implemented here, which is add subscriber. So its functionality would be to add the subscriber to this list. Remove subscriber is nothing but if you want to remove any of the subscribers from this list. And uh, place order is basically the action which is taking place. So whenever a client places an order, so I've just added a print statement just to keep the track when we run this end to end, that the order got placed for this particular order ID. And after that, we'll notify all of its subscribers. So basically, notify subscribers will make sure that whatever subscribers are subscribed to this service gets notified. So let's say if we have added two of the subscribers by invoking this method, add subscriber, that is inventory service and the notification service. So both of those gets notified. So that logic is implemented basically to notify the subscriber over here. So we run a for loop on this list, and we call the subscribers notify event. So let's say we added inventory service subscriber and notification service subscriber. So let's say when the subscriber type was inventory service, it will call its respective notify event, which is been present here, and hence it will do whatever the custom logic it has been implemented there for that particular order. So this is the order service class. And let's now check our main, basically the how this will completely, the data will flow end to end. So firstly, I created a subject in the main method that is the order service, and the observers I created inventory service and the notification service. And now I'm adding or subscribing basically this observers by invoking the method which is present in the order service class. So that is what I've called here. Now let's say we are placing an order. So let's say an order gets placed by a user. So once the order is getting placed, order is basically, this is the order ID, and it's for the product laptop, and its quantity is currently 1. And we will call the place order method which is present in the order service class. So whenever this place method order gets invoked, the order gets placed, and whatever the respective subscribers are for this, basically subscribing to this order service, which is inventory service and notification service, gets notified by calling the function notify subscribers. So whenever this method gets invoked, it notifies its respective subscribers for that particular order, and this method gets called. And so now let's understand it by running it in our terminal, basically. Okay, so I was currently in the wrong path, basically. Let me explain this off. Okay, so while running this, I got the details like for this order which got placed. We are sending the notification to the inventory service for updating its stock and notification service for sending out the confirmation for that particular order ID. So this is how this design pattern has been implemented here. Okay, now let's understand what key takeaways we could have from this design pattern. So first thing, it allows us to have a loose coupling. So here the order service does not have to care about like what type of subscribers are listening to it. It just broadcasts based on the list which or list of subscribers which it is holding. It becomes extensible. Let's say in future we want to have an analytical service also getting added here, then we just have to add that new module implementing our subscriber interface, and there will be no change happening at the order service class. Now, let's say we want to have some flexibility of in future, if based on the user's setting, we want that we don't want the subscriber to subscribe. Let's say we don't want to send out the notification. So we want to remove that subscriber notification from our list of subscribers. So that becomes very easier that we just have to call the APIs which are exposed in the order service class to add and remove subscribers. It also follows the single responsibility principle. So each of the module, being its inventory service, notification service, does not care about any other behavior of the other services. So they just focus on their own logic and the behavior, and each module has their own respective custom logics defined. So this becomes even more readable and even more easier to test or debug in future if there is some issue pertaining with our system. So yeah, that was pretty much about this design pattern. I hope you like the content, and if you have any particular feedback you want me to add in this videos, do let me know in the comments, and do hit a thumbs up if you really like the content. Do like, share, and subscribe. And that's it. Okay, bye bye. Thank you. Have a nice day.